book as she went through, so that was coming straight from your book. And that was the one you did after the quiz. I can't. Did y'all do it after the quiz or before the quiz? Yeah. Whenever. That was whenever y'all took the quiz the different day that third block did. But she talked about, and I hope you took notes as you went through, because like I said, she went straight through here. How about power functions first? Do you remember what a power function is? So it's when you have a function that looks like this, right? The x stays in there, but this is what we call a constant of what? Yay. See, y'all did learn something. That's my constant of variation. How do you tell if it's inverse or direct variation? If what's negative? If the power is negative, what's the power here? A. So when A is negative, what does that mean? It's what? Inverse variation. And when A is positive, it's direct variation. That's exactly right. What if it's a fraction? If the exponent is a fraction, does it matter? No, I'm still looking at positive or negative there as far as inverse or direct variation. I'll make sure I cover everything. What's the constant of variation? 2 pi. 2 pi is my constant of variation there. And these are straight out of your book. She went over these, but I just want to make sure you caught it. What's the constant of variation? That's right. What's the power? Inverse or direct? Direct. What's the constant of variation? K. Inverse or direct? Inverse. Why? How do you know the exponent's negative? It doesn't look negative to me. It's on the bottom. On the bottom means that my power there is negative 2. Boyle's law. Constant of variation? K. Is it inverse or direct? What's your power? -1. Y'all all okay there? Okay. Constant of variation? 1. What's the power? 1/3. Direct or inverse? Direct. Why is it direct? Positive exponent. Last one. Constant of variation. Direct or inverse? Inverse. -2. Everybody okay? Y'all said y'all didn't understand. Some of y'all emailed me and were freaking out that you didn't understand the ed puzzle. But clearly y'all understood something because you got it. You got it. Thank you, Adam, for that. But I'm not sure that I believe that. Then you talked about monomial functions. What's a monomial function? This is where there seemed to be some confusion. Anybody? What has to happen for that to be a monomial function? A positive integer. So what does integer mean? Not a fraction. That's exactly 1 to a whole number, right? Can it be negative? Positive. Yes. So over here, are those monomial functions? Why? Why is the first one not? 1/3, that's not an integer, and it's not positive. So those are not monomial terms. Give me an example of a monomial function. Somebody said 4x squared. Monomial function? Yes. Power function? Yes. What's the constant of variation? 4. What's the power? Direct or inverse? Because, look at y'all. I think those were the main points that I wanted you to really grasp from that section. Do you have any questions about that homework that you turned in from 2-2? You okay there? Like if it gives you like 17, the area of an equilateral triangle varies directly as the square. All right, so 17, the area of a triangle varies directly. And I always think about it, direct variation being multiplication and inverse being division, but as the square of the length of the sides. So very directly, remember that means I've got a constant variation, yes. So some constant of variation, it doesn't tell me what that is, times, and then I have my function, and it says it varies directly as the square of the length of the sides. So you can use whatever variable you want to use, but the square of the sides. If the length is x, the square of that length would just be x squared. Does that make sense? Y'all are oddly quiet today. Such a change from third block. Anything else on your homework there? All right. Do y'all need a brain break? No, right? Some people say no, some people say yes. Let me take a second while you switch gears from homework to notes for today, and we start today's new lesson. Y'all okay today? Oh my goodness, y'all. What is going on? Are y'all tired? Yeah. Oh man, third block's never like this. They don't stop talking. All right, let's talk about polynomials of higher degree. Again, this is going to feel like an Algebra 2 lesson. I apologize, but we're going to delve a little bit deeper into some things here. We've talked a lot about, in 2-1, we talked about linear and quadratic. Now we're going to up that just a little bit and focus on some other types of polynomials. So we know that if it's a degree, let's just talk about what they're called first. We know if it's a degree of 1, what's the type? Linear, that's right. If it has a degree of 2, what's the type? right? Then we start getting into a little bit higher degrees, a little harder to work with. How about a degree of 3? A cubic. What about 4? Anybody remember? Somebody said it. Quartic? And so these, remember, and I'll just sketch what they look like over here to make sure you remember. Linear, quadratic is, of course, my parabola. Cubic, and then quartic. And this is a very exaggerated quartic because we're going to look at some quartics today that do not look like this. And in fact, if you do the parent graph of a quartic, it almost looks like this or like this. Check out that. This is going to be a lot of analysis type questions too. What are extrema? Close. Maxes and mins, extreme points, really high or really low. So here I'm talking about, and this includes absolute versus relative. What's the difference? What's absolute mean? It never goes above or below the absolute, but relative is a high or a low in a specific point. What else happens with the graph at these points? Something changes. What changes? Somebody said it. Direction. Stops going down and starts going up, or stops going up and starts going down. It changes direction there. So these maxes are mins. I have, and this is something new we haven't talked about a whole lot. If I have a polynomial of degree n, just some random value, the most extrema that I have is 1 less than that value. So if I have a cubic, what's the most number of extrema that I can have? 2. If I have a quartic, the most number of extrema I can have is 3. Does that make sense to you? Maxes and mins. Just maxes and mins, right. So if I had I can't have any more than how many maxes and mins? 2. How many zeros might I have? 3. Remember when we talked in algebra that we know that this biggest exponent often indicates to us the number of solutions? So I know that it has at most, if I take the, bless you, if I take that same n that I'm describing there, that could tell me the number of zeros that I have. Typically, I'm going to have that many, but some of them might be imaginary. I might have some repeated solutions, and we're going to talk about all that shortly. Questions so far? So what I want to focus on today is not just this, but talking about in behavior, because I'm going to teach you a new way to write in behavior. Some of you have probably seen this before, the limit notation. Did they do that in the other section? I feel like they might have, and maybe you didn't. But we're going to talk about it for just a minute. In behavior, y'all sure you're okay? Starting to wonder. Limit notation. If I said that as x approaches infinity, f of x approaches whatever it is it approaches. This is the notation that you're used to, right? This says on the right side of the graph, what is the graph doing? Make sense to you? I can write this in limit notation, and when you see it, it looks almost exactly the same. I take all this and write it as a limit. I say the limit as x approaches infinity. And then whatever I'm looking to find, I put here. So the limit is x approaches infinity of f of x equals, and that's where my blank goes. Very, very similar, but this will be very important as we move forward, understanding this notation. So we're going to do several examples here, so make sure you understand. We'll do it graphically and algebraically. Yes, we'll do both ends. And it could be, as we've seen with some graphs, that we have to do the inside too. There may be a vertical asymptote somewhere that we have to describe. Instead of just two ends, maybe we have 4 places, like we did on that parent graph. Remember that reciprocal function we had? All right, so let me show you an example based on the graph. What type of function is this? Cubic. I can have no more than how many extrema here? 2. Do I have 2 extrema? I do. What do I have? What is this? My n, or my degree here, is 3. So that tells me I could have possibly 3 zeros and 2 maxes or mins. I'm going to say less than or equal to 3 zeros and 2. Are we all good there? Describe the in behavior here using limit notation. You try it, and then we'll do it together. This is too easy for y'all. Y'all are a tough crowd today. Sometimes I just feel like so awkward standing up here because y'all are just calling. I don't know. This is just normally you're bantering back and forth with me and at least saying Oh, did you? Was it hard? Really? You didn't think it was hard? He's got 2 sections of AP Chem? Well, this doesn't look good, Lily, because they're very dejected. They seem. I'm sorry. They seem.
Like you need to study that exercise. I studied them and I didn't tell some like fan don't do it. Yeah, I studied that and like I had no time to finish it out again. So since I didn't study, I'm not
Yeah. Thank you for making the correction.
Yes, I'm praying on direction.
All right. Let's do the in behavior. The limit as x approaches infinity of f of x equals what? Negative infinity. Unless it goes to a specific number, and it's only going to go to a specific number if it does something like this. This is exactly, that's why I said this might be too easy for you. But maybe it's a good thing coming off that chem test y'all just done. All right, how about the limit as x approaches negative infinity? Positive infinity. Okay. So graphically, it's pretty easy, right? But what if you have an equation? Like, what if I asked you, what the in behavior was? Oh, let's do something else. Do you remember how we classified in behavior based on the leading coefficient and the degree? Do you all remember that? Exactly. If you don't, I'm gonna give you the chart again, just in case you don't remember. Based on the leading coefficient and the degree. And let's see, the degree could be even or odd. And the leading coefficient could be positive or negative. I'll give you just a second to copy that down and we'll. All right. So if it's even degrees, that means both ends do the same thing. Either both ends go up or both ends go down. Think about a quadratic, right? So if that leading coefficient is positive, both ends are going to go which way? Up. Think about a parabola with a leading coefficient is positive. And if it's negative, then both ends are going to go down. So I can write the in behavior this one's both ends are going up. It's been so jumpy. Whereas if I'm on the other side, and my leading coefficient is negative, that would look like a parabola going down, or maybe it's a quartic, or even more. But those all, even degrees are always going to go both ways. And in this case, since that leading coefficient is negative, they're both going to go down. Does the limit notation make sense to you? You all okay there? Then then odd. Think about like a line or a cubic. Both ends are going to go in opposite directions, right? But you have to decide which end goes which way. I always think about a line that has a positive slope. Would look something like that. And that can help me determine, yeah, that would help me determine what the end behavior looks like on that. So here, what happens is I go to positive infinity. Anybody? Positive infinity on y, that's exactly right. And then the left side, negative. For an odd negative, that's just flipped around. So the limit as x goes to infinity of f of x would be what? Negative. And on the left, positive. Did I tell you gray means calculator or not? No. All right, so I want to go into your homework and do an example from each set with you that you're going to have tonight to make sure you understand which one that you like. Right? Yes or no? Okay. And I didn't talk about this a whole lot, but this was on your last test. For end behavior. Oh, I'm sorry. I didn't go back and answer the question. What's the end behavior of this function? So it's negative even, right? So that is the end behavior of that function. Sorry, thank you, Charlie. You feel like it's gonna fall? I'll see if I can find one to see. Is it like broke? I'll have to see if I can find one to switch that out with. So the graph of x to the fourth is the parent graph here. Do you agree? Directions say describe how to transform the graph of an appropriate monomial function. What's the monomial function here that I'd be transforming? Three x to the fourth or x to the fourth, whichever one you chose. I'd probably do x to the fourth because it's the parent, but that's okay, whichever one you want. Into the graph of the given polynomial function. Sketch the transformed graph by hand and support your answer with a grapher. So maybe we should do 3x to the fourth and then transform that. So if we started with 3x to the fourth, looks like, remember I told you a lot of them are just going to kind of even out right there. So if I start with this graph, something like this, does the end behavior there make sense to you? Do you see why it's doing that on the ends? Positive, even. Because if you think about to the fourth power, right? If I plug in as I get into a fraction form, so if my x, as my x is bigger, right, then to the fourth power gets really big. But if I'm closer, if x is like a half and I raise that to the fourth, then it's getting closer and closer to 0. You see what I'm saying? So that's why. Once I hit 1, once I go past 1, it starts shooting up. What would I need to do to transform this to get it to the green equation here? If this is 3x to the fourth, what are the transformations that would lead me to the green function? Y'all can do this. Down 2 and right 1. Yeah, Alex was asking why does it flatten out right there? And I was telling her because if you're on a graph like this, if this is x to the fourth, right? And this is 1 and this is negative 1, the closer you get to 0, so like this is a half, what happens if you raise a half to the fourth power? 2, 4, 8, 16, you get 1 over 16, which is really, 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 really small. If you raise 1 to the fourth, you get 1, but if you raise 2 to the fourth, you get way up here at 16. So the closer you get here to 0, the closer it gets to 0. So it looks like it flattens out, although if you zoomed in, you would see it doesn't really, it's not completely flat. You just have to really zoom in to see it. Does this make sense, the transformations there? How are we going to use that parent function or the monomial function is what we're calling it now. Because maybe it's not a parent function, maybe I can use a monomial to transform to find. Yeah. Yes, yes. That's why since it told me I could use any monomial function I wanted, I could go ahead and use the already stretch one because those are kind of hard to do. Other questions? And then transform it from there. Yep. No. Other questions about that? You sketch it. No, you don't have to do it. Yes, you'll sketch the green. So right 1 and then down 2. And when I say sketch, I mean really sketch. This doesn't have to be perfect. It also asks you to find the Y-intercept. What happens at a Y-intercept? Okay, algebraically, what happens? So if x is 0 here, I've got 3 times negative 1 to the fourth minus 2. What's negative 1 to the fourth? Positive 1. So what should the Y-intercept be? 1. Okay. Yes, no, maybe so. I've cried today. What's the number? This is not asked, but it's asked in the next question. They'll give you an equation and ask you to do this. And I'll just kill two birds with one stone here. What is the most number, or what are the most number of extrema I can have here? How about zeros? Not that the zero itself is going to be less than or equal to 4, but I can have up to 4 zeros of the function. It could cross the the x-axis up to 4 times. Everybody okay? What if this is no calculator, by the way? You are given an equation. It's in standard form, and you are given several graphs. And they are specific graphs that'll be a little bit easier for you to tell what's going on. But tell me some things to match this equation without a calculator to the graph below. What are some things that I can look for in the equation to see on the graph that'll make it a little bit easier to match up? Okay, extremas. Here I've got to have less than, you said, 2. So if it has any more than 2, that automatically rules it out, right? Nope. Nope. The Y-intercept. What's the Y-intercept here? What else? Okay, zeros less than or equal to how many? What else? The odd, the positive, the in behavior. That's exactly right, the in behavior. Here, I'm positive and odd, right? So it should be as x approaches infinity, what does the other end do? I mean, what does that end do? It goes to infinity. And as x goes to negative infinity, which one works? Does that make sense, how we're reasoning through that? Okay, so then there'll be 3 others there. I think that's it. I think that's all I got for you. Everybody okay?